All right, section 3.4, we're going to find and use slope of lines. And you see here, as a vertical line is kind of an exception, but as long as we're not talking about a vertical line, the slope is a ratio, so we typically write it as a fraction. We think of it as rise over run. Rise, we use that word to talk about the vertical change, so up and down. Run, we talk about the horizontal change, so left to right. And you can measure it between any 2 points on the line. So you see a picture here. We have 2 points. First one we call it x sub 1, y sub 1. The second one x sub 2, y sub 2. When we're talking rise, I typically start to the left, the leftmost point. So that would be this one right here. To get to the next point, I have to go up. So my rise goes from this y sub 1 to that y sub 2, so I subtract them. So they're saying y sub 2 minus y sub 1. Really, I could do it in the other order as well, but I'm going to subtract the y values. And then for the run, I have to travel to the right, so it's positive because I'm going to the right. And that's a difference of the x's from x1 to x2, so they take x2 minus x1. You can see the little formula here off to the left. We usually think rise over run for slope. Rise is measured as y sub 2 minus y sub 1. Run is measured as x sub 2 minus x sub 1. Couple things to know. If your slope is negative, your line will go downhill as you travel from left to right. The negative slope travels downhill. That's important to know because you can kind of double check things. Positive slope then, from left to right, travels uphill. Right here they call this a horizontal slope. I would also call it a zero slope. Because a horizontal line has a slope of 0. So let's draw a horizontal line there, but its slope is 0. It doesn't rise, but it does run. But a vertical line, you may remember up above I said the slope is a ratio if we're talking about a non-vertical line. A vertical line is the kind of exception. Instead of 0 slope, in addition to vertical slope, I'm also going to write undefined slope. And I'm also going to write no slope. All of those things are different ways of describing the slope of a vertical line. No slope can be easily confused with 0 slope. So make sure we understand that 0 is a number. No slope doesn't mean 0 slope. It actually means there is no slope because it actually has no run. Your denominator is undefined. So if we look at this example, we see 2 different pictures here. They want us to find the slope of both lines, of line A and line D. Let's start with line A. So A, I see from left to right it's traveling downhill. So we know it's going to be a negative slope. It goes through the point 6, 4, and it goes through the point 8, 2. Those 2 points I would call one of them x1, y1. One of them is x2, y2. And if you want to use your formula, you could just plug those numbers in right now. So you take the y2, which was the 2. From it you subtract y1, which was the 4. That's your numerator. In your denominator, take the x2, which is the 8, minus x1, which is 6. And now we can do this problem. Numerator, 2 minus 4 is negative 2. And the denominator, 8 minus 6 is positive 2. Now I can simplify that fraction. It is a negative over a positive, so it is, in total, it's negative. And 2 over 2 is equal to 1, so I would call this negative 1. That would be the slope of line A. Since we have the picture of it, I might have approached that differently. I might have actually just counted it. Instead of doing that formula, I might have started my pen at 6, 4, and I see that to get to the 8, 2, I have to go down, and I go down 1, 2 units. So that's a rise of negative 2. And then I run to the right. Since it's right, it's positive, and I go 1, 2, so positive 2. So notice I went negative 2 over 2, which is the same thing I got when I used my formula. So to get the same answer, there were just 2 ways to get it. So now, line D. Where is my line? Okay, line D is vertical, looks like. It goes through 6, 4, and it goes through 6, 0. If you try to count it, rise and run, like if I start at 6, 0 and I go up to 6, 4, I'm going up, so it's 1, 2, 3, 4. If you went from the 6, 4 and you went down, you'd have a negative 4 there. Either way, it's going to be okay. But then run, it doesn't run at all. So its denominator is 0. Notice if I would have used the formula, I'll probably, or I should get the same answer. Let's check it. So y2 is 0, minus y1, which is 4, over x2, which was 6, minus x1, which is 6. Here I get a negative 4 over 0. Whether it's a positive 4 over 0 or a negative 4 over 0, both of them are problematic because they both have a denominator that's 0. We're not allowed to have a denominator that's 0. We call that undefined. Which matches what I said right up above here. When we have a vertical line, we can call it an undefined slope. That's what I typically would call it. You could, I guess, say vertical slope or no slope as well. Any of those would be acceptable. So that's how you're going to find slope of a line if you know 2 points. And you see we also next talk about parallel and perpendicular lines. None of these concepts are completely new to you. You've done these before. This is kind of a refresher. But if we're talking about parallel lines, it says 2 lines are parallel if and only if. That's called a biconditional statement, remember? Okay. 2 lines are parallel if and only if they have the same slope. Biconditional means you can start with either part of this, the hypothesis, and the other one's the conclusion. It works both directions. So 2 lines force the slope to be the same, and if you have 2 lines with the same slope, they're forced to be parallel. Those 2 things just go hand in hand. So parallel lines, same slope. Perpendicular lines. They word it, I would say, kind of funny. Let me go ahead and read it, but then I'm going to describe it to you in a little different way. It says 2 lines are perpendicular if and only if the product of their slopes is -1. So if you multiply the 2 slopes together, you get -1. Another way to say that is that the 2 slopes are opposite reciprocals. For example, if I had 2/3, it's opposite reciprocal. When I say opposite, I mean the opposite sign. So 2/3 is positive, so the opposite would be negative. And the reciprocal of 2/3 is when you flip the numerator with the denominator, so 3 over 2. So 2/3 and -3 over 2, those are opposite reciprocals. Those are examples of slopes of lines that are perpendicular. I prefer to think of opposite reciprocals than thinking of the product of the slopes being -1. Okay, so in example 2, we have a picture. They want us to find the slope of each line and then decide which ones are parallel. They all look like they're at least pretty close to being parallel. Let's verify it, because you can't just say they're parallel because they look like it. We're actually going to find their slope. So K1 here on the left. It has the point -3, 0 and -2, 4. I'm going to start at the point that's further to the left. That's the -3, 0. I have to go up, so my rise is going to be positive. Positive 1, 2, 3, 4. And then I run to the right, which is positive 1. So 4 over 1, and that simplifies to 4. That has a slope of 4. I'm then going to check the next line, K2. I'll start at the 3, 1, and I'll go up. I'll go up 1, 2, 3, 4. To the right, 1. 4 over 1 is also 4. Are those 2 lines parallel? Yes. Let's check K3. Start at -5, 2. I go up 1, 2, 3, 4, 5, and over 1. 5 over 1 is 5. That is a different slope than the other 2. So K3 is actually not parallel to the other 2, even though it might have looked like it. So when they say now, which lines are parallel? K1 was parallel. Here's my parallel symbol. It's the double vertical bars. K1 was parallel to K2. They had the same slope. So now in example 3, we're talking about perpendicular lines. They give us some ordered pairs. We've got to draw these. Okay, so 3, 0, and 7, 6. So the first line goes through those two. We're going to need to know the slope of that line. So to find its slope, I can try and count it, although I don't have the grid. It makes it a little bit more challenging to count. So maybe we want to actually use the formula. So call one x1, y1, the other x2, y2. So this is the slope of line h. I'll give it a little subscript of h so I remember what line it is I'm finding the slope of. So y2 is 6 minus y1, which was 0. x2 is 7 minus x1, which is 3. 6 over 4 simplifies to 3 over 2. And now it says graph the line that's perpendicular to h. So we have to be perpendicular to that. So if we want to be perpendicular to the opposite reciprocal, it's similar to the numbers I used just a little bit ago up here. Opposite reciprocal, you're going to make the sign opposite, so we're going to use a slope of negative and then reciprocate it, so 2 over 3, negative 2 over 3. Tells us to go through the point 25. Let's start by graphing the point 25. And we know what our slope is. Our slope is negative 2 over 3. I'm going to go ahead and count that as rise over run. But you need to understand that a negative slope, you do not put the negative in both the top and the bottom. A negative 2/3 is not negative 2 over negative 3. In a negative 2/3, you can put the negative either in the numerator or in the denominator, but not both. I typically will put it in the numerator. So I'll think about it as a negative 2 over a positive 3. So from my point, my 2, 5, I'm going to do a rise of negative 2. So I go down 2, 1, 2, and then run positive 3. So 1 to the right, 3. 1, 2, 3. And then if you connect those two, we have drawn a perpendicular line. So that line there is the line that satisfies the question.